All right, we're going to jump ahead to lesson 11.1 today, just so we can finish all of our main core lessons by the end of the year. So we're going to have a lot of geometry concepts over the next few lessons, and this is a good preparation for high school. All right, it's going to maybe look confusing from the outset, but as you see the strategy, it's really not that bad at all. So today we're going to look at what is called a transversal. All right, so we start with parallel lines, two lines that are across. And this is going to be a line that intersects now. And what happens is it creates 8 angles when it intersects those two lines, right? And those angles now are going to have properties that have things in common. All right, so there's no way for you guys to, you could memorize these, but you're going to forget them over the summer most likely. So the whole idea is for us to understand the concepts behind them. All right, so let's just go over them corresponding. Let's look at our examples. So we have 1 and 5. All right, so they're on the same side of the transversal. You see that little shape right there? They are equal. All right, so take a look. On the opposite side, we have a bigger angle right here. All right, so this is what you guys need to remember. All right, is the difference between an acute angle. This is from, I believe, 4th or 5th grade geometry. It's less than 90. And the way you always remember it is it's a cute little angle. Okay, and then the other angle is going to be bigger. It's obtuse for over 90 degrees. Okay, so just remember that now when you're looking at these angles, because it's either going to be one or the other depending on where it is. Okay, so let's look at our next example. So alternative interior angles. So interior means on the inside. So take a look at 3 and 6. All right, I'm going to circle those. All right, take a look at them. Is it the bigger one or the smaller one for each of them? They're both bigger, right? So they're both obtuse angles. So notice how those are both equal right there. All right. So next we have alternative exterior angles. So exterior means on the outside. So we got 1 and we have number 8 right there. So you see right there, is that the acute or the obtuse? Those are both smaller, right? So those are going to both be equal, 1 and 8. All right. So again, it's like basically a flipped mirror. All right, and then lastly, same side interior. All right, so on the interior, on the same side, 3 and 5, take a look at those. Take a look at the shape. That is bigger, that is smaller, so those are not the same, right? Those are going to be, you're going to have to add those up to get your 180, which I'm going to talk about in just a second here. Okay, but that's what same side interior means on the inside. All right, so let's look at our concept here, and our concept is called supplementary angles. All right, so you guys did this back in the day, and this is the whole idea, is that when you're going from one angle to the next, there was our obtuse angle, there was our acute angle. Those two that make up a straight line are always going to equal 180 degrees. Okay, so here's a couple of examples that I'll show you. All right, so take a look at this first one. All right, so here is your smaller angle. You need a bigger angle, and the two of them from here to here need to add up to 180 degrees. That's just what you always have to remember. Another way for you guys to think of it, if it's 180 to go from here, another 180 going around is 360. All right, so now you need to subtract what you have to get to this angle. All right, so x equals 180 minus 35. Make sure you borrow the right way. So this one is 145 degrees. All right, so that's how you find x. The two angles will always add back up to 180. Take a look here. How do you find angle x in this one? So you're not thinking of the top anymore. This is a new problem. All right, so you're going to start again, because I know both of those angles add up to 180. I subtract 118. Once I do that, I have 62. So 62 degrees goes right here. And I can check my work by adding, and they both get back to 180. Okay? So that's the whole idea here. And now that we understand that, is you guys can go back and we can use that whole idea of back and forth. All right. So take a look right here. So if angle 1 is 30 degrees, okay, so I'm going to write a 30 right here. What does angle 2 have to equal? It equals 180 minus 30, right? And once I do that, that equals 150. Now I can set up the rest of my angles, because I see this is a small angle, and those two are the same right there, 1 and 4, so I can write that there. This one and this one are the same, so I can rewrite that, 150. Now I'm going to go down, okay? This one and this one are not the same. That's a smaller angle, but this is my concept, that both of these are the same. And now both of those are going to be the same. So they're always going to add up to 180 going across, going this way. So this one right here also has to be 30, and that was one of those vocabulary words that we looked at right here, right? Alternative exterior angles. And then here and here, 150. All right, so if you're given one angle based off of these transversals, you can figure out all the other 7. So kind of a cool concept. All right, so let's take a look at this example now. So state the measure of angle of an angle if angle 1 is 100. All right, so again, here let's write in 100. So now I can figure out angle 2. What would it be? I need to get to 180. How do I do that? I subtract my first angle, and now it gets me my remainder, which is 80. Now I have all the information to fill in all the other 7. So I can go across. Notice how that is bigger right there. So that's 100. This is 80. Now I have matching. All right, this is right here the same as this. All right, so that's 100. And this is going to be across. That's 100. And then next to 100 is 80. And across this way is 80. So I found my 8 angles when I had 1. That's the whole idea behind it. Take a look at textbook. Shows you the same thing. All right, so again, another way to think of it is if you start at a point and you go all the way around, also known as a circle, right? How many degrees in the circle? 360 degrees. So that's adding all 4 up and they get you there. All right, so let's look at a couple more examples. All right, so what is angle 2 when angle 7 equals 125? All right, so here's 125. So now I need to find this angle. All right, so take a look at it. Is it going to be the bigger one, or is it going to be the one that goes with it to get 180, which is smaller? And this one you can just see that it's bigger, right? So it's going to be the same. That was one of the vocabularies, okay? So those are bigger. The other angle would have been 55, and that would be angle 1 at the top. All right, so a lot of different ways to look at it depending on where you start. Here is a type of word problem that you're going to see sometimes. All right, so this is what a civil engineer would do. So if this angle right here is 48 degrees, what is the question mark angle? So take a look at it. All right, is that a bigger angle than the one right next to it? All right, so you notice how those two are matching. All right, so that is our concept here of our transversal. So it's not the 48, it's going to be the supplement of 48, which goes with it. So I have to subtract. Okay, so 132 is your missing angle. All right, and that would also go right here, right next to it. All right, so let's go down. All right, find angle VMZ. So VWZ is 3x. All right, so this one's a little bit different, right? So I'm trying to find 3x, but I don't have any angle degrees. And so this is where you're going to have to use algebra. All right, so both of these on the inside always add up to 180 because we have the smaller the acute and the bigger the obtuse. So you're going to have to use math now to solve 9x equals 180. All right, so combine your expression. 9x equals 180, divide by 9. Both sides are going to be divided by 9. X equals 20. That's not my answer now. I need to go back and plug it into my x's, right? So 3 times x would be 3 20s, which is 60. And this one here is 6 times x, which would be 6 20s, which is 120. I just need to find my right angle, VWZ. VWZ was the 60-degree one. All right. And this is what you're going to do. Okay, so you're going to use these concepts now to solve for your last 4 slides. Again, remember to come to class because it helps to go over these things and you get more credit than you would by doing this, right, if you get wrong answers. So don't forget right here, all right, find the angle measure. All right, so right here we have for GDE. So take a look, GDE, we're looking for that angle right there. All right, so you're going to have to use algebra again to solve for x. Remember that adding the 2 of them up are going to equal 180. That will get you your x, and then you can use that to solve. All right, so on the rest of the problems, you have, just to show your work here, take a look here. I would write in the amounts on your piece of paper or such, and remember to match them. All right, so AGE when FHD is 30, so find FHD, there's 30. So now you're looking for AGE. All right, so is that the same looking at it as the 30 degrees? Is it the same, or is it the supplement that goes with it? Right, so that's the purpose of your assignment today. Any questions, let me know. Otherwise, have a great day.